We are on equilibrium of forces in physics, and I want to take the first example. You can see the diagram here. The question is, calculate the magnitude of the tension T1 in a string shown above if the system of forces is in equilibrium. We are asked to find the value of this tension T1 if the system is in equilibrium. Okay, so we have tension T1 on this string, tension T2 here, and the weight of the body acting vertically downward. You can also see that tension T1 is making angle 60 degree here with the vertical, right? So we are asked to find the value of T1. Now let's go. We can see that T1, the tension due to T1 is an upward force. Okay, so since it is an upward force, we need to go back to it again. We need to balance the upward force. Okay, this force due to T1, this tension T1 is the one that provides the upward force, although it is making angle 60 degree with the vertical. So we need to balance the vertical forces. Okay, T1 is acting upward and the weight of the body is acting downward. So we need to balance them by equating the vertical component of T1 to what? To the weight of the body which is acting downward. So it means that the upward force which is due to T1 could be equal to the weight of the body which is acting vertically downward, because the two forces, the tension T1 and the weight of the body, are vertical forces, although the T1 is acting upward and the weight of the body is acting downward. So what do we have? We know that the vertical component of T1 from the solution of vector, you see that T1 is making angle 60 degree with the vertical. So the vertical component of T1 will be T1 cos 60 degree. Okay, we just multiply T1 by the cosine of the angle between T1 and the vertical. So the angle between vertical direction and T1 is 60 degree. So to find the vertical component of T1, that is along this direction, vertical component of T1, we multiply T1 by cos 60 degree. Okay, so that gives us the vertical component of T1. That's why we say T1 cos theta is the vertical component, and theta in this case is 60 degrees. So that means T1 cos theta is the same as T1 cos 60 degrees. Now, to balance the vertical forces, we have that total upward force is equal to total downward force, right? So the upward force is T1 cos theta, which is the vertical component of tension T1, and the downward force is the weight of the body, which is its mass times acceleration due to gravity. So the mass of the body is 10 kilograms, so that's going to be 10 times 10. We are taking acceleration due to gravity as 10 meters per second square. Alright, so this is the weight of the body which is acting vertically downward, and this is the vertical component of tension T1 which is acting vertically upward. So this is upward and this is what? Downward. Now equating them, we have T1 cos 60 degree. Cos 60 degree is what? 0.5. So that means T1 times 0.5 is equal to 100, because 10 times 10 is 100. Divide both sides by 0.5, we have T1 to be 100 over what? Over 0.5. 100 over 0.5 is 200. So T1 therefore is what? 200 Newton. So the actual tension in this string, according to the diagram, this T1 therefore is 200 Newton. Okay, that's the actual tension here, 200 Newton. Right, so that solves the problem, and I hope you understand and actually be able to solve any similar question like this. Again, the basic concepts applied in solving this problem is: one, we need to understand how to resolve this tension T1 vertically. Right, so that means we find T1 cos 60 degrees, not T1 sin 60 degrees, because this is a vertical. We need vertical component of T1. So once we have gotten that, then we need to balance the vertical forces. That is, upward, total upward force must be equal to total downward force. The downward force is the weight of the body, which is its mass, 10 kilograms, times acceleration due to gravity, which is also 10 meters per second squared. So when we equate that, we get the value of T1 as required. Thank you for watching this video. Please, I'll appreciate it if you like this video tutorial, if at all it helps you in any way. I will also be glad if you subscribe to my channel, because I'll be updating it with new videos on for many examples on equilibrium as touching physics. Thank you very much.